My name is ERIK. My name is ERIK ESCOFFIER. I am a front-end engineer, a coder, and I do maps. The first thing I want to say is that I'm working and living in Madrid, and this picture is just to prove Miria that we also have beautiful mountains here in Madrid. So I'm into maps. I'm a self-confessed map nerd, and there are many reasons for that, but I just want to borrow words from Jason Greenblatt. I love maps and their promise of fractal discovery. There's really like this infinite discovery that cartography offers that I'm really into. And that has been going on for a while. That's me when I was 5, I think. But only recently, actually, about 3 years ago, I started making web maps a professional activity, a full-time professional activity. And so when you're an engineer and you do maps, you're not very likely to do cool pirate maps like this. What happened to me was that I did a lot of thematic mapping. So as you all know, thematic mapping is cartography that focuses on a specific phenomenon using choropleths and that kind of stuff. And I loved it. I still love it. I love to do that. And in general, when you do thematic mapping, you have something behind that is called the base map that serves the purpose of giving your information some context. So you just pick a map style, such as positron from Carto, for example, and then you go on with your life and do your thematic mapping, right? So this time, and this is the reason for this talk, I want to specifically talk about this base map. But really, not exactly the rendering, but the data set that is behind it. That really is the ultimate data set, because that data set is the map of the world. So that's the data set that aims at representing reality. I find it fascinating, and in general, the database that powers those base maps is OpenStreetMap. That is a free map of the world that is usable by everyone and editable by everyone. And that's what this talk is about. OpenStreetMap aims at representing the natural feature of this world, but also the human-made features. Country boundaries, big lakes, peaks, highways, railways, subways, theme parks, roller coasters, ski tracks with the difficulty, shops, the opening hours of bakeries, a huge amount of data. And I have to say that the map is only a byproduct. It's only the final result, and what I want to have a look at in this talk is the actual data. And I do believe that OpenStreetMap is worth our attention. And I'm going to try to give you a few tools and ideas on how to consume that data. So you have to begin somewhere, right? And OpenStreetMap can be a bit impressive. So maybe a good thing to try first is just poke at it. There's a tool for that. It's osm.org or openstreetmap.org, which a lot of people tend to compare with Google Maps, but the purpose of this is completely different. It's a tool that is aimed for people that contribute to the map and people that consume the data. It is not a general purpose tool. And for example, what we can do on osm.org is use a tool called Query Features. And this is exactly the hotel where we're in now. And we sort of, that's exactly that, poking around, and then we see various geometries around. We see that there are different types of objects, some boundaries, some objects that seems to be a composite of nodes, circles, and boundaries. And really, the data model of OpenStreetMap is very simple. You just have 3 basic primitive types. There are nodes, correspond to points, to points in geometry, ways that can be closed polygons or just lines, and then you have something else that is relations that sort of ties all of that together and allows you to attach metadata to a set of geometries. And that's about it. And so to understand a bit how this works, for example, the hotel is a building. So that's a way. And we have something else that is interesting, is the tags. The tags are the actual metadata that is attached to all elements. So for example, here we can see that the facade color, we can see the date of construction, no surprises, the 70s, and we can even see the architect. So there's a lot of data, and actually you have a wiki page that lists all of the tags, not exhaustively because it's not possible, but there's a lot of them. And that's interesting because that's basically a catalog of the things of the world. So I find it amazing. You have another tool called TagInfo that gives you some metadata about the metadata, so you can know the popularity of a given tag, for example. And so sort of putting all that node polygons relations together, if we query, for example, a metro station close to here, we have a node that is the subway station that is attached to a way that is a portion of the metro line. And then to understand more the complex concept of relation, we have this relation that is actually a composite of all the metro stations and the metro line. And there's some metadata here that is interesting as well, the color of the line. So now that's about discovering the data, but how do we consume it? I want to talk about a first tool that is called Overpass. That is the front end, but it's actually an API and also a query language. And so you have a wizard on Overpass Turbo that generates this. For example, if you look for parks. So and you get a bunch of geometries that appear on the map and a query that you don't understand. And one thing that Overpass does not do is explain to you the code that it generates. So step by step, this is a very basic query where we ask for all nodes that have the tag tree in the current visible viewport, which is a convenience offered by Overpass Turbo so that you don't have to put latitudes and longitude. You get not only geometries on the map, but also a lot of data and metadata as XML by default, but can be served as JSON. And that's maybe the core of Overpass. That's the recursion operators. So for example here, if we ask for a node that is a bus stop, and we ask for the parents, that is the backward recursion operator, we get the relation that this node is belonging to that is not visible on the map because a relation does not have a geometry. But if you then, again, with the same thing, do forward recursion operators, we get the bus line that the bus station belongs to, as well as all the stations. So those are the first code slides of the day. I hope you enjoy that. Another example that I really like is you can also query for an object with a name. So you ask for the Seine River, close to where we are right now, close to the Eiffel Tower, and you actually get something that is on a country scale. You get the whole river. And so this is for reference. I'm not going to go through all of this, but it could be useful later for if you need to do that. So that's nice, but we want to be a bit more creative. So we have a thing called OpenStreetMap Haiku. That is inspired a lot by this amazing project called Everything Every Time from Nao Matsuda. And her idea is to generate poetry based on sensors, on smart city sensors. So there are sensors all around in Manchester, and some computer-generated poetry appears every second. So we took that idea, kind of, and we went with this idea of OpenStreetMap Haiku, which would be somehow similar, but it would work for any place in the world using OpenStreetMap data. That leads me to talk about how you get data in a certain area using Overpass. So you have one way that is using a polygon. So you give a bunch of latitude, longitude coordinates, and you get something like this that are all the shops roughly in the city center of Valencia in Spain. Another option is to use named relations. And in that case, we got all kebabs of United Kingdom, for example. But what we really want to do with OpenStreetMap Haiku is get all things that are around the point. So we give a latitude, longitude coordinate, a center point, and then we give a radius in meters. And that gives us, with backward and forward recursion, so kind of aggressive recursion, we get everything that is around the point, which is something that then we can, that query, we can send it to the Overpass API and use a template to dynamically do that for any place in the world. And just only keep the geometries that actually have tags, because we want to generate text, right? So we got a big JSON with a lot of interesting stuff. The next step is to generate the poetry, so it's very simple. For a given tag, we generate a given verse. We can have conditions, so for example, a sentence that is only generated if there's a building that is above a certain number of floors. And then to spice things up, we use another API, that is the OpenWeather API. So we can have also conditions that are based on current weather. So for example, talking about a coffee shop only in the morning. So that's not the weather, that's actually the time, but also generate things if it's raining, for example. And that's the result. This is in Paris, so you go everywhere, and you get something about a boat. That's how it works in New York. So yeah, that's an experiment. Thanks. So I have to move on, so I'll just leave this here with some generative zen. The next experiment is about hairdresser humor in France. But basically, that is a pretext to talk about consuming data at country scale. So to put that in context, we have a thing here in France where hairdressers have shop names with puns, terrible, terrible puns. There's even a Tumblr about this, so it's kind of like a cultural phenomenon, I guess. I find it fascinating. So how do we, if we had to do a study about this, how would we proceed? So there's a shop hairdresser tag on OpenStreetMap that we're going to be able to use. Overpass might not be the best tool for that because you're going to run into problems. That's more related to Overpass Turbo, but you're going to also hit API limits. You're going to hit API limits. So the strategy instead is to download a portion of OpenStreetMap data locally and run the analysis on our machine. The dataset that we use, in that case, there are many other ways to do that, but that's the one I want to talk about. We're using a dataset called OSMQA tiles. That is a subset of the whole of the OpenStreetMap data. It doesn't have everything. And you have the whole planet, 25 gigabytes, and you have country extract. So in that case, we're going to download country extract for France, that is 3 gigabytes. And then alongside that, we use a strategy called MapReduce, that is, and TileReduce is a project by Mapbox that implements this strategy, where it's basically a way to parallelize computation and running stuff in multiple cores. So it's not that complicated, actually. The simple idea is that on the right, you have a script that works at the tile level. And you do processing here, so in our case, collecting the hairdresser shop names. But you could imagine more complex stuff like doing geospatial stuff, computing areas, doing buffers, that kind of things. You can also collect geometries, not only data. And so you do that at the tile scale, and you send that back to the script on the left. That is the reduce part. That is the aggregation step, where we get stuff from our parallelized scripts. And in our case, we generate a CSV file that is composed of the 100,000 hairdressers in France. And this thing takes about 2 minutes to run for the whole country, so that's not too bad. And yeah, so it's not very useful, actually, but I have to admit. But I would like to see that fed into a neural net, for example. That could be interesting to see if puns can be done by neural nets. Yeah, and so it's just for the French people here, sorry, it's just really bad. Or gross, like it means hair on the soup. And this one is just not very confident. But so that's just a silly example, but there are smarter people than us that actually did interesting stuff with using OpenStreetMap data and to do a piece. So that's from Dataset, analyzing the influence of history on the street names. I recommend checking out our project. It's really good. Completely different, but I want to go up in scale, so we're going to work at the planetary scale now. And the idea, sorry for the pun, the idea here is to do ski map of the world. And it's interesting because ski maps are almost like a sub-discipline of cartography. There are artists, there's actually a book about that is really good. And in terms of OpenStreetMap, that's also interesting because that's a feature that doesn't show up in the main map, so you actually have to look for it. And the tag that we use for that is piece type, and then we have downhill for ski and Nordic and sled and so on. And the interesting thing also is that the difficulty level of the ski is also an information that we can use, and then we can use that to color code the resulting map that we're going to do. So same strategy with tile reduce, except this one at the planetary scale. So of course, this is going to be longer to run, so I recommend doing that on a test dataset. So you do that on Switzerland, that is 300 megabytes, before doing the 25 gigabytes thing. And that's extremely simple here. We collect geometries for features that have a given tag, so the ski tracks, and then we get that back on the reduce part, and you write to the standard output a GeoJSON. So that's a pretty big GeoJSON for the whole planet. It's about 100 megabytes. So you're not going to be able to just render it with a leaflet, for example. You're going to have to process that and make it into vector tiles. So for that, we can use Mapbox Studio. There's a workshop tomorrow about it, just so you know. So I'm not going to go deep into Mapbox Studio, but basically this is what we get, and then we can style using those difficulty levels. And actually going one step further, we can pre-process the difficulty levels so that we have something that works for every part of the world, because the difficulty levels match with the colors is not the same everywhere. So we have different rules, and depending on latitude and longitude, we can just directly have the color encoded and just let the renderer or the styling tool be dumb about it. So that thing takes about 2 hours to run on my laptop with the 25 gigabytes planet file. The base map is from Amy Lee from Mapbox. It's called Swiss Ski. And it's inspired, Swiss Ski. It's inspired by, there's a blog post about it. It's inspired by the work of Imhoff, amongst others. An extra touch is adding the labels, because those ski tracks actually have names on OSM, so you can, and using the right parameters, you can have the labels actually follow the tracks. So here's the result. This is Switzerland, and then we can move on to Japan. With you can notice the difference in colors. And this is really what I think I was talking about when I was talking about a fractal dataset, right? I mean, you can explore to the infinite, and it's also a nice visual representation of how vector tiles compression works, because it's kind of obvious how the features got simplified at lower zoom levels, and then you zoom in, and they start to get more complex. And there is one optional step that is interesting, is that when you upload a GeoJSON to Mapbox, the process of converting that to vector tiles is kind of arbitrary, in the sense that it will decide for you what are the optimal zoom levels. So for example, here, you do that and you can't see your ski tracks below zoom level 4. And then beyond zoom level 9, you get maybe geometries that are simplified too much. So there's a tool to actually do what Mapbox is doing locally. It's called, this tool is called Tippecanoe. And it's basically cutting the middleman, right? I mean, it's running that on your machine so that you can decide arbitrary zoom levels. And there's a whole bunch of options to simplify geometries. That's a pretty powerful tool. Also takes a while to run, but then you can upload the result of this, that is an MBTiles file, directly to Mapbox, and then you can see that it sort of respected your zoom choices. The MBTiles file is nothing complicated. It's just a database where each tile is a line, and you have tile coordinates, and then a binary blob of whatever's in the tile. So it's easy to work with. And then as a bonus, because I just got implemented in Mapbox GLGS, client-side hill shading. That's just for fun. Half experiment, maybe in the spirits of Moritz, art of tidying it up. So we started working on a series of posters for theme parks because there is an abstract beauty in roller coaster tracks, and we find that quite beautiful. I don't have enough time to actually detail the process to produce that, but just so you know, it's using converting the GeoJSON files to SVG is using a tool called MapShaper. That is from Matthew Block from the New York Times. And I think the only problem with MapShaper is that it's just too humble. It can actually do much more stuff than what it advertises. It's a really, really powerful tool, and it's amazing work. But for something completely different, let's forget ski tracks and a final experiment that is the world in emojis. So we started working on this. It's a very simple and silly idea where we have this leaflet plugin that converts a GeoJSON file, so GeoJSON polygons, to emojis. So what it is, eventually, is just a string of Unicode characters. So we tried that with various data sets. This is endangered species by taxonomic group and country. This is the American Human Development Index. Those are not Chernoff faces. This is a simple emoji choropleth. What we find really fascinating with that is that because it's text, it can be copy-pasted, and you can do GIS in Slack, for example. So we're really into that idea, and we tried different things, and this is actually a bivariate emoji choropleth. So maybe for Martin to add to the Xenographics collection, I don't know how many stars. But going back to OpenStreetMap, there are two layers on OpenStreetMap that are land cover and land use. Land cover for natural features, and land use that are for human-made occupation of the territory. And sort of joining those two layers together, we tried that on a local scale, so that's an island on the coast of France. And we have like this sort of Zelda-looking cool map of land cover. But obviously, we wanted to bring that on a global scale, so we wanted, because why not? Because why not having a global map, emoji map? So the good thing is that on Mapbox Streets, that is the OSM subset that you can use on Mapbox, land cover and land use is available, so we don't have to produce our own dataset. We can just simply use whatever already exists. And also, I want to mention that there's another option than Mapbox that is OpenMapTiles, that is made by a German company, Clock and Tech, I think. And that's a really interesting alternative because it's open source, so you can host it yourself. And so you put that into a leaflet this time, and you have a GeoJSON layer rendering polygons. And the strategy here is it's a performance trick, actually. So we render this GeoJSON layer into a canvas, into bitmap data, and then we use pixel color information to render the emojis. It's just faster than doing point and polygon. And so the result is something like this, where, for example, we are in London, and so you go there, you zoom in, you pan on the map, and then you copy-paste it and tweet it or whatever. So yeah, that maybe sums up the whole talk. Yeah, we try things and we see if it works. I want to conclude by talking about the humans that are actually making that data. So the humans of OpenStreetMap that are working on those now 4+ billion nodes of OpenStreetMap. So those are the 4.4 million users of OpenStreetMap. So it's a diverse, very rich data set with a lot of dimensions. And the interesting thing is that everything is the result of a consensus, and there is a debate about everything. So there are such things as path controversies in the OpenStreetMap world. People discuss whether it's a good idea to add carpet hangers as a feature on OpenStreetMap. People discuss the way we should represent house number. Should we use the Unicode character, or should we use just 1/2, for example? So it's a whole world of data, but the data is only diverse as the mappers are. And there has been some controversy recently about representativity of OpenStreetMap users and the impact. There's actually been a study, and the impact it has on the data itself. So I like to quote that from the mysterious account Anonymaps. Preppy Silicon Valley kids training machine learning models to trace buildings, and birded or Europeans surveying beer gardens do not a full-featured map make. And I think I like it. I like the idea, even though I'm maybe one of the demographic here, but we need more diverse people, we need more families, we need more women, we need more people of color contributing to the map. And there are recently more initiatives. This group called GeoChicas, for example. One of the projects they did is to map the Hispanic cities and try to map whether the streets were named after a man, a known man or a known woman. So another good resource for more diversity is the humanitarian branch of OpenStreetMap that's doing a lot of interesting work. What I want to say is that despite the whole controversy, the whole thing is, the whole conversations are happening in the open because that's the nature of OpenStreetMap. And I think that's the true quality of OpenStreetMap and maybe what makes the problem less of a problem. While there's a lot of controversy around OpenStreetMap, but the point is that other map providers, you can't know because the discussions happen behind closed doors. So to conclude, I would like to encourage you to try to contribute to the map. Gregor told me yesterday, I live in Berlin and everything's mapped there. So there's not another city in the world where that is as much true. Yes, Berlin is pretty well mapped in OpenStreetMap. But still, you can find places like, this is a hike that I was doing on the mountains near Madrid. And you get stuck in a path, the data is wrong, you fix it, and you feel good about it. So I really encourage you to do it. It's kind of addictive. And also, there are a lot of local communities, so you don't have to stay alone. There are a lot of mapathons for humanitarian OpenStreetMap, where you gather around and you draw stuff on top of satellite imagery. It's an interesting way to meet people. Don't forget the attribution. And that's all I got. We're a satellite studio. We're a young database studio and mapping studio based in Madrid. And I want to take the opportunity to thank the other half of Satellite Studio, Juan Carlos Alonso. Amazing designer and amazing friend. So thank you. And yeah, the slides are available at this URL, and please go and talk to me if you have any questions about what I talked about. Thank you.